Hey everybody, Matt Wallace from Faction, and I'm joining you today to talk to you about how you can leverage multi-cloud to transform your data practices at your enterprise. I've now had the amazing privilege at Faction to work with some of the coolest, most innovative enterprises, and I'm taking a lot of those lessons learned to talk to you about things that we can do, things that you can learn from, best practices, and some traps and tricks. So let's just kick things off and talk about problems people have around data. Enterprises today deal with all sorts of interesting challenges. Collaboration, integration is one of those. And a lot of this you see, in the highest level as a disconnect between folks who are working on, say, data warehouse teams, business intelligence teams, and then people who are on a machine learning data scientist team. And they have different objectives, different ways of using data, but often it's the same data. Sometimes you have people in finance, people in marketing, and they're leveraging those exact same data sources and data sets to drive value for the business. And yet it actually becomes very difficult for them to all work together on account of this sort of inability for them to easily access the same data, collaborate on the same data, sometimes enhance the data. And so what we see here is difficulties collaborating. And I would say another thing that is spoken not very much of because it tends to be underpinned by very private business arrangements is collaboration between businesses. So for example, we had one customer that had a very large repository of genomic information, and they were leveraging that genomic data so that they could develop pharmaceuticals and things of that nature. And they really wanted to partner with another enterprise that was leveraging Google Cloud, even though they had largely situated their workflows into AWS, but they didn't have an easy way to share that data. They certainly didn't want to create and share multiple copies. They didn't really want to even give custody of that data to the other party per se. They certainly did not want to have multiple copies that were out of sync with the sources of the data. By leveraging Faction gives them the ability to continue to use the data from AWS in the exact same way that they're doing it, and then also share the data over to their partner in Google Cloud using that workflow that was really dependent on Google Cloud's Life Sciences API. That's a really great example of collaboration outside of the enterprise. Cost is a big deal. I don't want to really dive too much into this, but at the large scale, especially for large enterprises that find themselves wanting to access data across so many environments, we find them making many copies. It could be 2, it could be 7. There's data transfer costs associated with that. There's the duplication of data. There's also the duplication of effort that goes with that, right? And we're talking about things like applying metadata to multiple copies. Some people don't realize it's a copy of a copy, and so they're doing backups of a copy of data, things of that nature. Sometimes people are modifying copies and data lineage gets muddy because you don't know which one of these was the original copy and which one is the modified copy. If they're not the same, it's arguably even more difficult to deal with than if they are the same. Good example there of things that you can incur when you're kind of dealing with that data sprawl. Innovation and change is a bit of a big deal, and that really ties back into this idea that people who are out to do things radically to transform the business want to move fast. They want to leverage services. They want to be creative. They want to use new software and services, and they certainly are finding things all the time spread across the cloud providers that can help them on that journey. That's become more true as the cloud providers have become more differentiated from one another. We're not living in 2012 anymore when everything that was coming out in one cloud was basically some sort of table stakes thing for another cloud, right? Where everybody needed to have the same instance types, the same GPUs, the same object storage, the same types of block storage, and the differentiation was much more minimal. Obviously there were leaders, right? You had AWS out there kind of innovating at a faster clip than most. You had Azure kind of catching up to that. But nowadays, the kind of table stakes services are really tied off on, and what you see them doing is truly innovating at a different level. And how does that look from the perspective of who's serving healthcare better, right? With Google's healthcare specific NLP service, which actually, I believe Amazon just finally announced a competitor to, even though the Google one has been out for quite some time, or the fact that Amazon has Bedrock to train customized versions of foundational models, but AWS not only will allow you to train somebody else's foundational model, they're making their Palm 2 models available so you can fine tune and train those, and that's available now. These are great examples of huge differentiation between different cloud providers. But when you have your data set, how do you take advantage of all those services across all those clouds? This is something that has really baffled and confounded some of our customers for some time until they got to Faction and they realized they could take advantage of all these services at the same time. Governance is another big problem, and we see people wrestling with this in many ways, shapes, and forms. And we don't really directly solve a governance problem because we are not a governance layer per se. However, if you can winnow yourself to a single copy of data or minimize the number of copies, then you make the job easier because you do not have to keep data lineage multiple times. You don't have to apply metadata in multiple places. You don't have to decide, do I keep every copy in one catalog or do I proliferate multiple catalogs so that each team has its own catalog of the copies of data that it has made? Things like that become a lot easier when you can narrow down those number of copies. And so this is just a subset of things that we see. And now I would really like to tell you how it is that we can address some of these things in a way that not only takes care of these challenges, but unlocks a world of innovation possibilities for you. To underpin all of this, I really have to talk about the difference between multiple clouds and multi-cloud. And multiple clouds is actually the thing I think of when I hear a lot of people talking about what they mean by multi-cloud. And they'll use phrases like, it's a workload that's spread across multiple clouds. And they will literally say, that's multi-cloud. I don't really want to debate the semantics of it, right? I'm not out to prove that the multi-cloud term means one thing or the other. But I do want to be clear that when I talk about multi-cloud, I'm talking about what I like to call true multi-cloud, which is the version on the right. It's leveraging different clouds at the same time for different reasons for some form of strategic advantage. And it could be something as simple as leveraging the cheapest spot instances in every cloud so you can do an HPC workload at the minimum of cost. And we've seen that done, and we've even proven that out in some of our research using, for example, scale-out GPUs spread across every cloud only on spot instances to do massive petascale genomic analysis. But we also see it in terms of an innovation play, right? Where you can pick a service from one cloud and a service from another cloud. And the difference here is that by combining the best service for each thing from each cloud, you're able to build something that's novel and better. And a good example that I like to draw on, because it's a pet project of mine, is that when the ChatGPT API came out, I actually started to build a voice interface for it. And I immediately wanted to use Google for the text-to-speech to say things back to me, because I thought the Google text-to-speech voices were absolutely unparalleled in terms of how good they sounded. But I really wanted to use OpenAI's Whisper API, probably inside of Azure, to do the speech to text, because I found it was absolutely superior to every other choice in terms of correctly capturing what I was trying to say. And so you get those differences, and that makes a big deal. And then I went to go graft phone dialing onto it so I could actually call ChatGPT on the phone. But it turns out Twilio, which is kind of one of the most well-known services for doing that, is something that's running inside of AWS. And there's some advantages that make it easier to generate speech from a voice or speech from text if you're willing to leverage AWS Poly, because Twilio is already inside of AWS. Amazing the way that these things work. And so it's a great example of how all these different myriad services can tie in together. And I'm going to talk a little bit about more of this differentiation at that platform service level much later on in the deck when we talk about these AI-driven services and how they are incorporated across the cloud providers. So with that having been said, I think it'd be remiss for me not to stop and talk about what it is that Faction does, because I'm talking a lot about problems we see with data. I'm talking about really cool things around building complex multi-cloud applications and the architecture that you can drive. But I don't know that that necessarily gives you a great view of what's going on in terms of Faction and how we operate. And so if you take a look at this, this is a great high-level overview. You can see Faction sitting here in the middle with our Cloud Control Volume product. It's a fully managed multi-cloud data service. And, at the user and user level, it really operates a lot like any other object storage platform, like any other file system for an NFS mount or HDFS or SMB, etc. We can even expose block volumes, although it's considerably less popular because of the sort of limitations that many applications have around being able to use block volumes simultaneously from different clients, right? Because you have to deal with your own locking mechanism. It doesn't come along with the protocol. We tie really well to on-prem things. We have customers that come to us over all kinds of different dedicated Ethernet lines, EPL, EVPL, so on and so forth. And if you look, for example, at point-to-point lines, MPLS, we're capable of doing all those things. And so once we have this diverse ecosystem of ways customers to connect to our network, which is totally optional, right? You don't have to connect an external network or an on-prem. We have this data service embodied in an object endpoint, embodied in an NFS endpoint, et cetera, crisscrossing our Faction Internetwork Exchange. The Internetwork Exchange is where Faction's kind of secret sauce lives. It's where our IP is. We have 10 patents on fancy network technologies that are mostly about distinguishment or security or interoperability at that multi-cloud layer to enable all kinds of overlapping networks to crisscross into the cloud at extremely high performance with a lot of security involved. And then from there, we let you easily turn up connections into Amazon, Azure, Google, Oracle Cloud. I want to be clear, though, that when I say turn up a connection, I don't mean that you go and procure a connection. I mean, our fabric is already wired in, that we are already working with the cloud providers, that we already have massive amounts of direct connect and express route and interconnect connections that we can leverage in order to get your data into these cloud providers and so on. And so it's a much more unified experience, not one where you're designing a network architecture, not one where you're standing up network equipment, whether it's physical or logical, building SDN layers. It's something where it's turnkey. And additionally, we are putting the things that back the data service, where the data is actually stored. We put in our data centers that are extremely close to the cloud provider equipment. So we are absolutely minimizing the latency here, much more so than any other architecture I have ever seen. And I'll actually show you some screenshots of our latency later so you can get a feel how astronomically low. What people underestimate, though, is how much of a difference latency can make at this very small scale. And if you think about this, this is all very small numbers. But if you're at 1 millisecond of latency and you change that to 2 milliseconds of latency, there are many applications where that cuts your throughput in half. The simple fact that everything is taking twice as long to transit the network means that it will be half the speed. That's why we pay a ton of attention to this, so that every spot, from physical, logical to operational, we pay a lot of attention to the fine details at the network level. So with that, what is it using it like? And it's super simple. And what you can see here is a screenshot on the left of a cloud service. We picked AWS Glue Studio. And in this case, it's the ETL. The visual ETL function of Glue Studio is actually reading data from Faction's object service. It is applying a mapping to it to do ETL on the data. A simple one here where we're just transforming two of the columns, and then we're writing it back to a Faction object again. So working seamlessly inside of a cloud service. On the right-hand side, you can actually see just mounting it up as an NFS mount, right? This is the output from a DF minus K. Well, it's not K because it's gigabytes, but you can see this is 475 terabyte volume. That represents less than 1% of our maximum volume size. So we can actually present 50 petabyte volumes into multiple clouds at the same time. Like in many cases, it's enough to hold all of an enterprise's data. For some of our customers, they have larger data sets than that, but we're still able to hold a massive amount of that data. It's very cool. We actually show right below this a screenshot of the genomic analysis use case that I mentioned a little bit earlier. This is literally dozens, and this is a cutoff screenshot. We had hundreds of instances of this, all processing the same genomic data as part of the same gigantic HPC acting as this HPC cluster acting as a supercomputer all at once. And all of them are able to have this exact same data mounted. So they're able to read the same data when they have a job, which can be distributed arbitrarily to any node in the cluster, regardless of which cloud it lives in. That node can access the exact same data at the exact same mount point in the exact same way, regardless of which cloud it's living in. There's nothing to it. And that's simply because the place on the network that the Faction data service lives is being advertised as a network across all the private connections to those clouds. So the workloads that are in Amazon see the route from Direct Connect. It goes directly to your VNet. Your instances access it just like it's local. Same thing in Azure, same thing in Google, same thing in Oracle. And that really unlocks some incredible possibilities. No one does what we do. And so because we have this turnkey managed way of delivering that multi-cloud experience, it lets you get off the ground and actually deliver this. But it's not just quick and easy. We've actually designed this and we've proven out in independent third-party reports being able to do hundreds of gigabits of traffic and drive this to enormous scale, which really no one else can do. And so it's really the only choice for doing this at enterprise scale, short of spending just absolutely enormous amounts of time and money kind of building out this technological capability yourself. And we deliver it as a service in a way that is so economical that some folks literally use our service to save money. Even though they're in a single cloud, they only have a single copy of data, they still find it super advantageous to leverage our service for that workload. So good example here too, being able to use some of the third-party cloud-based SaaS offerings. So we're talking about Databricks, we're talking about Snowflake, this incredible ability to leverage us as the backend for those, right? Snowflake, it's the external table, which they can do with other parts of data. With Databricks, truly is something you can access through all of those constructs like DBFS, directly as an object service, et cetera. And we've got, replete examples of this. Actually, it's usable both as file and object, although Databricks obviously internally sort of has a preference for object, if you will, sort of designed and structured around it. And I would say it's sort of more widely tested to do something like Delta Lake on top of Databricks. We've also published some joint white papers with Databricks and Dell, or Snowflake and Dell, for example. We've shown, all multi-party integration of these things and being able to even leverage them with third-party tools like, for example, Power BI for visualization. So really powerful set of capabilities here. So if you look at something like this, we're showing some of the other cloud services here, and you can just see there's all kinds of things. And I mean, a good example here being a SageMaker notebook and a Vertex AI notebook are very similar services, typically used by some of your data scientists, machine learning practitioners. Being able to actually have, one team leveraging the notebook of their choice, with the platform of their choice, with the kind of back-end tools on that cloud provider of their choice in one cloud, the other team doing it in another cloud, or even parts of the same team, and they get access to the same data in the same way, at the same time, and the same speed, et cetera. And that even that data can crisscross, right? A great example here being, you can literally train a notebook in one cloud with Databricks. And if you've put the model and artifact repository in the middle on Faction, then you train the model from another cloud, say somebody's testing a different feature, et cetera. You'll actually see different versions of the same model appear on the back end. We're almost like turning separate workspaces into shared workspaces via that multi-cloud power. We show Athena here too as another good example of a tool. Obviously, Athena is more of a SQL querying engine, from a data warehouse perspective, but again, kind of showing that compatibility with using these tools of their choice. And I think this is where things get really interesting for me, because I get to show off some of our speeds and feeds type numbers. And what you see here on the left is a screenshot of our monitoring platform. We call it Canary, as in the coal mine, because we certainly want to know if any cloud provider is kind of struggling from a network perspective, so we can kind of deal with that on behalf of our customers. But what you'll notice here is that we're monitoring these incredibly low latencies. This is the 6 availability zones of Amazon in US East, Northern Virginia. And you can see we're ranging for each zone from 0.68 to 1.18 milliseconds. This is the fastest speed I've ever seen. And it doesn't surprise me, because our fabric is truly designed physically, logically, operationally to leave as little as possible to chance, right? Take every edge that you can find and try to fine tune things so that you can get the best possible performance, the highest throughput, the lowest latency. And this really is like getting to the level of, for many use cases, as good as in the data center. For many types of applications, something that's running at sub-millisecond is almost indistinguishable from your workload running on your compute hardware, dealing with your storage backends in your data center, if you have one, and we're perfectly happy to do pure cloud native things. But I think as a parallel, it's kind of interesting to think about how fast that would be. We've certainly had a lot of customers who have told us that they have gained performance moving onto our platform for certain types of services. On the right-hand side, we're showing the API that we have and just a tiny portion of the user interface for actually creating a new connection into cloud, just driving those different workflows, whether it's automation or whether it's human-driven workflow. And so with that in mind, I do want to spend a little bit of time talking about who uses this and how they use it, to really give you an idea of how people are tapping into this to drive some improvement in their enterprise. Take a tiny break then again. So, great use case to start off with. And this is a fantastic example of the simplest transformation yielding such positive results. And so we had a customer who, as you can see, was modernizing their patient care information system, right? Modernizing their Epic EMR environment, petabytes of data on our giant file service. And in the back end here, we are talking about, something that is serving millions of end users, right? Involves patient records. There's millions of dollars at stake. And you can read through this testimonial and kind of understand how we're able to really drive like transformational change for these workloads. What's interesting about this to me is that we don't really have to drive a multi-cloud outcome in order to drive some of these values. But as you get into the multi-cloud aspect of things, we amplify our value basically exponentially. So we had a Fortune 100 company. It's modernizing, doing a data center evacuation. They had a complete business unit that was trying to completely leave the data center environment behind, go fully cloud. And it was appropriate for them with their architecture, but they had some interesting requirements, right? They had to be multi-site. They required replication. They had to have write once, read many media, right? The idea that once you put some data into place, there are policies and mechanisms on the back end so that it cannot be deleted without like excruciating levels of approval and override. And we were actually able to help them with that. The business unit was the first to achieve basically a full cloud migration of this enterprise where they were able to take 100% of their workloads completely out of the data center. And they were able to realize, the savings and agility associated with this. And part of that was because we were able to deliver a much better platform to deal with their massive data that they were moving. Another great example here, working with a global bank, they have a fantastic data practice already kind of driving bottom line numbers, and we were able to provide them an object service. And it really helped unify two different sides of the business that were using AWS and Azure separately, but also drove all kinds of interesting interactions where they were able to start really letting their teams use the best tool and the best cloud for the best purpose. So really powerful there. And that gives you kind of an idea. You can see all kinds of different use cases in all kinds of different industries here, where we're able to kind of make a substantial difference for people in the way that they're able to architect their cloud environments, for how much they have to spend for them, the scale that they can achieve, and so on and so forth. And I really love this slide because there is an enormous amount of complexity here. But the thing that you'll really notice is on the left, we show these data processing workflows happening in each cloud. And that's the reality. Every cloud, and on-prem as well, they have their own ways of dealing with all of these services. They have tools for so many jobs. It's possible for you to have different teams that are doing the same thing across every cloud, that's storing one or more copies in every cloud. But the problem with that, of course, is you have all these penalties, the duplicate copies, the complex integrations that are different for every cloud, the dollars you spend moving data between clouds, the complexity of the processes that are involved because of all of the sprawl of the data, synchronization problems because nothing is really synchronous transfer of data when you've got multiple copies, even aside from the operational complexity. So then you look at this, our vision, the unified multi-cloud service. And now what you can see is these workflows are still operating, because remember what we showed at the start, all of these services and these common protocols accessing Faction at the same time. But what you see here is there's this common data plane cutting right through the middle of these things. So instead of having many copies of the data, you have one unified multi-cloud copy that substitutes for all these copies. And now things are simplified because you are able to you're able to centralize the metadata. You're able to centralize the catalog. You're able to reduce the number of operational processes to interact with that complexity. Obviously, you're only having to pay for one copy as opposed to 4 or 7, because not only can you use this across every cloud, but we make it easy to federate across every team across an enterprise. We've had customers with literally thousands of VPCs inside of AWS that needed data access. And we're the only service that has an architecture that's designed really with that kind of scale in mind, where you're not having to solve that problem yourself or pay excruciating amounts of money to do things like connect everything to transit gateways or duplicate your network connectivity many times over to connect the sprawl of VPC environments that you have. And so we solve for that. And there's a little complexity to that. Like we actually have to show a whole different slide to talk about the network architecture, but it is enabled and it simplifies things greatly. Having one identity set where you can do one SAML integration to our platform to consume your IDP, as opposed to many different identity integrations, is just another example of how we simplify some of the governance and security concerns. So I love this. I'm a big proponent nowadays of AI, so I love including them in the slideware. And obviously, this data scientist is super happy about being empowered with his data. But I love having this little screenshot, and it's a little bit of an output where we were dumping the output of a catalog of tables that were being managed through Hive server, where you can actually see here that there are the bottom two tables here are actually tables that are running on Factions object service. And the upper table is actually a table that's inside of S3 natively. And the crazy thing about this is you can have these tables with this metadata managed in a central catalog, and you can literally have data in Amazon and Azure and Google and Oracle and Faction, and you could literally run queries that join data directly across all of those clouds from that central environment. Now, of course, I think the vast majority of that data, the multi-cloud accessible data, you're going to want on Faction because our platform makes it easy to consume it from everywhere. But I love the fact that we can directly integrate tools in a way where you can consume the Faction data and the public cloud data at the same time in the same SQL query. And that's why this guy is so happy. Of course, it's pretty interesting and powerful. And, getting to have all of the outcomes at the same time, where you have a happy team that's dealing with traditional apps that can touch that data and have it be, strong enough, fast enough, good enough for a traditional workload, having happy data scientists that can do the work that they want to do, having a happy CFO who spends less is kind of the trifecta of wins for us there. So, one of the things that we find, and I touched on this earlier, is that you find these data teams that sometimes are disconnected. They're doing work across disparate clouds, right? And I want to touch base again on this idea because we're showing again here the Vertex AI notebook on top, the SageMaker notebook on the bottom, right? But it's really as simple as that, right? Just given basically a simple init script or a config file, depending which cloud you're in, that teams deploy, now they can all have the same access to the same data in the same place, the same copy, not multiple copies, not synchronized, not moved on the fly, presented across Faction's super performant network fabric into every cloud. So we're not moving data, we're not replicating it. There is no software-defined storage layer, as it were. You're just using a protocol where each cloud at the network layer is able to tap into the data source as if it was local to that cloud, because we have used our data center footprint, our extremely tight network fabric, our dark fiber, et cetera, to drive the performance that delivers that millisecond level capability so that everybody can be using that data from each cloud at the same time while feeling like it's really local to them. So a funny thing is, this then empowers you and moves you on towards multi-cloud data management. And this is a sort of theoretical architecture that we put together to the very first time we kind of saw this requirement to help a customer understand how they could leverage Azure Purview. So Purview is like a catalog service. It's, I think, based loosely on Apache Atlas, but it's the kind of thing you can essentially use to keep track of what data do I have, where does it live, and then you can actually start cataloging it to some extent, indexing that data. You can apply all kinds of metadata to it. So you can do things like keep track of certain types of lineages and retention rules and things of that nature, right? But one of the things that becomes powerful is that leveraging Faction service, you could actually apply that to all the data also that's living in Faction and literally then potentially even in the other cloud providers. even possibly traversing our network backplane, because although it is not enabled by default, the network backplane we provide that connects our data service in each cloud can, if you turn on this feature, become essentially a transit gateway between clouds as well. So literally you turn it on, you create those cloud connections, but as you add those cloud connections, we are actually re-advertising routes so that your Amazon network sees your Azure network and vice versa. And we actually have the ability to incidentally carve up our fixed network exchange. We can actually carve them up into subfabrics. So you can actually have completely, essentially isolated network domains. Think of that a little bit like a VPC set of networks where they're completely isolated from one another. So that enables some other powerful architectures as well. So I'm really passionate about AI, as you might have gathered from my AI generated artwork, but I'd like to talk to you a little bit about what AI means for multi-cloud, because it's obviously a fairly new thing to see AI. I did do a whole webinar here on Bright Talk about it just a few weeks ago, and I would totally invite you to check that out. I think it was titled something like Super AI Superpowers from Multi-Cloud. But honestly, that talk was really more about AI in general and very little about Faction and the service, because I was really focused more on helping people understand, what AI is capable of, why they should be interested, how some of these things work before getting into how do we help. But I do want to spend a little bit of time today talking about how Faction plays in this rapidly expanding, very interesting AI space. So what I have here is a comparison chart, and I'm actually comparing 3 of the big cloud provider services that do image recognition. Those are obviously AI-driven services, right? They use convolutional neural networks to do vision, computer vision against things. And what I've categorized here is 3 different pictures, as well as a comparison of how they treat emotion handling, which is also to say sentiment analysis, right? If you hand them a picture of a person, they don't just tell you it's a person. They can say, is the person happy, sad, angry, etc. But you'll notice that it's different things across each of the APIs. You'll also notice that there's huge differences in the output here. And let's take a look at one, right? So the top one here of the actual images is a screenshot of Google Maps. And you can see that Azure actually has one of the best things here. They say map 99%. So it's kind of a tied as a top one. Google Vision API 92%. I find it weird that they're in second place because it's literally a Google Map screenshot. And then AWS coming way behind with map, which is this 60% one. And then you look at this dog, again, recognition is getting it animal, dog, or at the top. I have no idea why it thinks it's a golden retriever, because it's a little black dog. That doesn't make a ton of sense to me, but there it is. And it's interesting that there's so many things tied for top. Like, to me, it's obviously a dog. Canine almost feels like it's a synonym. But seeing things like mammal and pet, I just don't know. So Azure Computer Vision does the best job here of finding it at 99% chance of dog. So it's the clear top one choice. But it's interesting too, because if you look, Google Vision API did 98%, also really good on the dog. Although again, golden retriever, I just think that's so weird. But then if we flip the dog upside down, right? And this is a fairly common practice incidentally in terms of training computer vision models. People often take the image and they'll do things like crop different parts of it out, flip it, rotate it, etc., because they want to train the model not to only look at things from the exact angle that we sort of see it natively on the training data. So what's interesting now is if you look at Azure Computer Vision, which was the number one, identifier of the dog, it now drops dog to 42%, and it says it's ground. And that's 99% likely floor, sidewalk. So basically the dog almost becomes invisible. Even domestic cat outweighs dog. So funny as a human being, of course, because you look at it, you go, it's a dog upside down, right? But computer vision is funny and quirky that way. And finally, there's a comparison between file formats. Now, what was really interesting to me is this sort of comparison is something that I stumbled upon when I was really doing a lot of research about ensemble learning. And ensemble learning was a way of building machine learning models where you could have essentially multiple models, and there's different ways, honestly, of doing ensembles, right? There's a paper that had just come out when I first started talking about this called the super learner, basically was the architecture that was proposed. And they had shown the super learner model could produce better results in an ensemble than the base model it was derived of. And so what I mean by that is, imagine you have a machine learning model that identifies, is that a dog or a sidewalk? It has a certain level of performance, 92, 99, whatever. But instead of training one model and just having it do an inference, you actually train 5 different models. And literally the only thing that's different about that training process, same data, same code for training, just a slightly different initialization vector. You end up with 5 different models at the end, and they should perform quite similarly. And they do, except what you find is that if you take those 5 and put them into an ensemble, you actually can eke out higher performance. And the example that was in the paper was 95% accurate top 1 or top 5. But then when they had the ensemble with 5 copies of that model trained, voting as an ensemble, they were actually able to achieve 96%. And obviously at that sort of like extremely high performance, eking out additional performance gains becomes substantially trickier. So it was really powerful they were able to do that. But the interesting thing to me is that while they were training only on an ensemble comprised of 5 versions of the same model, it's just as possible to actually have multiple models working in concert where they have actually different underlying features and they emit totally different inference, but you have something like a super learner that then takes all those different models and actualizes sort of best answer from that group. In the context of public cloud, I would say, look at recognition, computer vision, Google Vision API. They're substantially different. And they're not necessarily going to be good at the same things, right? So just because one of them does best at the dog doesn't mean it does best at the map. It doesn't mean it does best at the boat. And so being able to actually go to each cloud and leverage different services across each cloud to kind of get a better result than you could in a single cloud, that's where multi-cloud really shines. And in the era of AI, and I'm going to jump into this now, I'm really enthused about this. There are so many reasons why you might want to tap into multiple cloud services across different clouds. And so here I have a kind of simplified chatbot example, right? Where a customer comes to an AI-driven chatbot and they basically say something. In this case, they say, "Hi, my name is whatever, Amanda, and I have an appointment Friday for a cut and color, but I need to move it to Tuesday." And so it goes through the classifier, and the first classifier is a pass at an LLM to just say, is this message safe? Now, most of the LLMs have inherent safety controls, but a funny thing is that there are cases where the safety control might actually not detect that it's unsafe, but if you use, that's partially because it needs to be faster and easier and less expensive. If you can use the larger model to then do a safety check, you can say, is this message safe or not safe? And so you're able then to take that, and once you've classified it, if it is safe, you can then go into assessment phase. And in this theory, the assessment is actually doing something from a customer service perspective. It's asking, are my customers happy? Or are they at least neutral? Or are they upset? Because the theory is if they're upset, you're not just going to have a normal chatbot conversation. You're going to route them to like a supervisor or somebody else. So you can have like a much more in-depth conversation. You can intervene to kind of save, some of that customer service goodwill. But assuming it's normal, and this is going to be most messages, it's going to get routed into what does my customer want? And you might actually at that point send it to different models. So in this case, the model would go, oh, they're trying to reschedule because I know what that message means. So I'm going to send it to a scheduling specific model that understands dates and times and calendar access really well. And so that model gets in. And of course, in this case, we're actually theorizing that that model runs on a fine tune of Google's Palm 2. That's the Palm tree. And it could be because Palm's good at this, or it could be because we just want to run it in Google because it's easier to access the calendars because they're based on Google Calendar. So either way, we do, like an API call. We're seeing all kinds of evolutions in the chatbot space where LLMs are being empowered to kind of interact with external services. Of course, when you're doing your own app, you can do it however you want. Make that call, check availability, generate a reply to the user. You get, of course, an LLM. One thing it's good at is having a very polite conversation. But nonetheless, we want to make sure it's not going haywire. And so we actually take the response from Palm, feed it into the OpenAI evaluator. Again, it's going, does this message really appear to address the request of my customer? Because if it doesn't, we don't want to say something dumb. We want to actually route it to a human or take another try rather than make some kind of like totally errant assertion in this chatbot, right? Safety is obviously a bigger concern for the enterprise than kind of random end user use that we saw in the earliest days of ChatGPT. Finally, we're going to use an LLM again just to say, is this message safe? Now, of course, there's like questions about what's the performance of these routes, et cetera, but it's an interesting example. And I think it's a fairly reasonable version of a real world, multi-cloud, multi-model chatbot workflow designed to deal with all kinds of different concerns and that interacts with the customer in different ways. But you can't execute this inside of a single cloud, not with any kind of data that you want to have kept off of the public internet, because you're going to want to go to OpenAI. It's only running in Azure cloud. Obviously, you can only use Palm for inference inside of Google Cloud. Now, this is an LLM specific one, but there are so many other examples. And in the future, you might truly see, for example, people building chatbots, and maybe the chatbot is multimodal, or even LLM-based applications. You might have a multimodal LLM, but maybe you do want to second guess what's in this image before you completely trust the language model with the imagery. And so maybe while you're talking to OpenAI, you're also asking Google Computer Vision, what is this thing, et cetera. And so I think those really pose interesting questions about how you're going to leverage services across clouds. But it's also a really interesting example because these services that are running across different clouds, they operate completely differently. Like there's no question that you were getting different answers and different sort of performance of answers, if you will, from OpenAI APIs, Anthropic APIs, Palm APIs. And so how do you choose the best thing? And in the future, we're going to be thinking not just about like what produces the best answer on like a leaderboard. We're going to be asking questions like, which of these is most cost effective? Which of these is the easiest to fine tune? And all these questions. And it's going to lead us down a road where there will be different answers depending on the use case. And so that leads us to this. So, really powerful, really interesting use case. And with that, I have to say, we're not going to be able to do questions today, right now. However, I would encourage you to reach out to us at www.factioninc.com. You can find me on Twitter. My handle is @MattWallace. You can also find me on LinkedIn. Ping me there. I'm always happy to hear from people who are able to watch some of this content and hopefully get something out of it. But I definitely encourage you to reach out to us and learn a little bit more and see if you can empower your enterprise with multi-cloud data services today. Thank you and have a great day.